Instead of the usual Christmas lights that skies over Star City in Pasay were illuminated by fires in the complex. The fire allegedly started inside the stockroom of Star Games. It quickly spread throughout the complex due to the flammable decorations.
So, for the meantime, di kayo makapag-operate ngayon.
Investigators are looking at two possible causes: electrical overload and arson.
Tinitingnan namin yung electrical at saka yung arson. Hindi siya normal kasi nakita natin sa loob, mayroong lugar na sunog. Patapos.
The fire lasted for 14 hours and the damage is pegged at 1 billion pesos. Jack Batallones, ABS-CBN News.
Live in the city of Cebu, TV Parol 24 Hours presenting Electrical Fires as the Engineering Problem, Heat-Sensitive Outlet, the Elevator Pitch. Presented by BSCPE 1 students, Ayesha Chryll Ardoña, Rhea Ann Dela Rita, John Jimmy Arseo, Emerson Josephus Espere, Zachary Bardoquillo, Jeddah Laine Luceñara.
Electrical fires start with wires, cables, circuit breakers, and other electrical components. Overloaded circuits or the age of the panel can also cause fires. When electricity distribution is insufficient, the panel and circuits become overloaded. Lighting equipment can occasionally operate as a heat source that is too close to easily combustible items. When an outlet overloads, the circuit breaker trips, cutting off power to the entire circuit. In the absence of a circuit breaker, the circuit wiring will overheat, causing the wire insulation to melt and potentially igniting a fire. It can endanger a family, property, and the entire neighborhood.
For the proposed solution, our idea is an outlet with a heat sensor which can be made by using Arduino. It is possible to create it with a few tweaks to the outlet. Arduino is a very good and versatile piece of technology that can make interesting projects. We will create a contraption where the outlet is capable of preventing electrical fires only by detecting heat and then cutting off the electrical supply from the outlet.
So here are the materials needed. This is a summary of it. First, we have the outlet components, which are the AFCI outlets, the Arduino, basic Arduino components, heat sensor, and printed circuit board, and also we will be using soldering tools. So first, we have the outlet components, specifically the AFCI. So AFCI stands for Arc Fault Circuit Interrupter. So a combination of AFCI outlets at the beginning of every circuit and an AFCI circuit breaker will protect houses from fire hazards. So next is an Arduino. So what is the purpose of sensor for Arduino? So it can obtain sensor values, and sensors are devices that convert a physical quantity such as light or intensity or temperature into an electrical quantity. And the Arduino components are the components that make up the Arduino itself.
We will be needing also the heat sensor, which measures the amount of atomic activity inside an object. This is what we think of as an object's temperature. Printed circuit board, or the PCB, which is used to mechanically support and electrically connect electronic components using conductive pathways. They enable all of the complicated communications that are required for electronic devices to function. And lastly, we will be needing the soldering tools, which is used to join different types of metals together by melting solder. Solder is a metal alloy made of tin and lead that is melted with a hot iron. To produce a strong electrical connection, the iron is heated to above 600 degrees Fahrenheit and then cooled. And here are the procedures on how to create an outlet with a heat sensor. Step 1. Create and test the Arduino contraption that contains the heat sensor, in which it is set to give feedback when the heat it detects is equal to the heat of a fire, and it cuts off the electric supply.
Step 2. Create a PCB or printed circuit board that can support the mentioned Arduino contraption.
Step 3. Assemble the Arduino contraption to the printed circuit board, then solder them.
Step 4. Create a modified outlet to fit the printed circuit board with the Arduino contraption.
Step 5. Attach the contraption to the outlet and test if it works.
Step 6. Revise if needed.
It only takes one mistake to bring us all down. Don't let it be yours. Keep calm and say no to electrical fires. Keep safe.